The last thing we're going to talk about is igneous rock textures. Right? How can we look at a rock, look at its texture, and identify it? And when I say texture here, I don't necessarily mean something you can feel with your fingertips. I mean the texture you visually see with your eyes, right? The size of the crystals is what I'm talking about. Right? So whenever igneous rocks cool intrusively beneath the Earth's surface, the crystals have plenty of time to grow, right? Low, slow cooking, right? And when that happens, they're able to grow really, really big, creating a coarse-grained crystal structure, which we call phaneritic. A good example of this is granite, right? I look at granite, I can see those quartz crystals, I can see the plagioclase crystals, I can see the biotite crystals, right? So that's phaneritic texture cooled intrusively. Extrusive rocks, they become in contact with the atmosphere or with water. They cool so much faster. They don't have a lot of time for those crystals to grow. So those crystals remain small, fine-grained, and it creates an aphanitic texture. And the crystals are so small, you cannot see them in hand sample. Right? When I look at this piece of basalt, I can't pick out one mineral from another. It just all looks black to me, right? So that's aphanitic texture. I could pick out the crystals if I saw it under a petrographic microscope, right? But this is just a hand sample. So those two textures you should have already been familiar with. Now I'm going to introduce some that you might not be as familiar with. The first one is porphyritic texture, and this happens when you've got a little bit of both, right? This happens when a magma or a lava cools in two different stages. The first stage is relatively slow, right? So this is going to be intrusive, slow cooling. Large crystals are going to start to form. These large crystals we call phenocrysts. Then say this magma is erupted to the surface of the Earth and the rest of it cools very quickly. So around those large phenocrysts, you get a fine-grained ground mass, right? And so the texture might look a little bit like this, where overall, it's aphanitic, but there's a lot of coarse grain crystals in there. There's a lot of phenocrysts as well. And we call this, this texture porphyritic. Next up, we've got a glassy texture. This happens when the lava cools so quickly, almost instantaneously, that there's no time for any crystals to form at all. All right, so if you look at obsidian underneath a petrographic microscope, you won't see any crystals. It'll just be kind of like a shattered glass mess. And just for your viewing pleasure, because I think it's super cool, obsidian can come in lots of different colors depending on what sort of minerals are incorporated into it. You can get red obsidian, snowflake obsidian, the one with the little white specks on it. You can get rainbow obsidian with all sorts of different colors. This is from the magnetite that's being incorporated into it. You can even get a blue obsidian, right? It's pretty cool.